Welcome back to Console Cowboys. In the last video, we covered how to perform a full replay attack with only the YardStick 1. We can leverage the RF command line tools to sniff data into hex form so we don't have to convert it manually. We can then replay that attack with only RFCat and a bit of Python, avoiding the need for GUI-based tools and opening up the ability for automation. In order to start automating our RF attacks, there are a lot of little tricks we'll need to learn. A way to sniff that allows us to set data into variables, the proper format needed to parse the data and actually send it. While the data coming back looks correct, it's not really as it seems. First, we'll load up our RFCat command line and paste in our options like we did in the last video. And we're going to try out a new way to sniff the traffic, the RFReceive command. RFReceive is useful because we can actually set it to a variable and then use the data elsewhere in the program, but there are a couple gotchas with it. First, we need to use a while loop. If we don't use a while loop, then it'll stop listening after a second, so we need to keep listening over and over and over again. However, if it doesn't hear something right away, we'll also get a chip USB timeout exception, so we'll need to use a try-catch block with this in order to capture it. And then we can pass the exception and continue listening. So let's do that now. All you will need to do is just copy-paste the chip USB timeout exception from above and paste it next to the accept line. Once we do this, we'll type in pass, so that way every time this exception comes up, we just continue on. And if we hit go and start hitting our alarm, we'll start getting data back. However, our data is a lot of hex data that's really messy. We need to get this in a format that's a little more readable, kind of like our listen command. So let's set that up with a variable and encode it. We're going to do this with a script instead of the command line. It'll be easier for us in the long run. If you take a look at this script, it's the same as what we typed in the command line, except that we import the RFlib at the top, and then we set our receive to a variable, y and z. If we're looking at our data, we have something here, then we have a comma, and then we have something here. So we're just going to grab all of this and we're going to dump it into the y variable. We're going to encode the y variable with hex and store that hex data in the capture variable so we can print it below. Let's take a look at what this looks like on the command line when we actually run the script. When you run the Python script and hit the doorbell, you'll notice that we get back a lot better looking data than we did before. Kind of like the data we got back from RFListen, except this time it's set to a variable we can use. Now that we have some data back set to a variable, we need to be able to actually parse that data and use it. You'll notice there's a bunch of extra zeros in our output that we don't really need, so let's parse that out. Pretty much anything with multiple zeros we want gone, and then we want only the data I just highlighted. We'll set that to the payloads variable, and we'll run this script, except this time when we get our output, right underneath our output, it should show a list of all the variables that it parsed. We can loop through each of these hex values, format them, and try to send them over to the YardStick directly to attack our target. If you're a little lost by any of the code, please check out the blog where we explain things in a bit more detail. This is more demonstration purposes and for visual learners. This loop highlighted is used to format our data in the proper form needed to send it over with the YardStick. One thing I learned is that we can't just send over our data in a hex format string like we created it manually. If we do this, it sends it over literally instead of the form that we need. So what we need to do is take the payloads that we have and turn them into binary data. And then once we have the binary data, we're going to use bit array to turn them into the proper byte format to send them over with our YardStick 1. You'll notice the difference in the output when we actually run the program. You'll see two different forms. You'll see our binary, and then you'll see random characters that are unprintable. This is what we're sending over. We're not sending over a literal string representation, which is what will happen if we try to parse it into a /x format with our actual Python program. We'll send it over literally like that and it won't actually execute. So this actually makes it work. There's a lot more detail on the blog and a couple more demonstrations on the blog, so you'll definitely want to check that out if you want a little bit more detail. So here's an example script that'll automate everything. It's pretty much the same thing you already wrote. with a couple changes. So this first part is going to capture the transmission just like you did before. The only difference is we create a capture variable above the while statement, and then we use an if statement that says if we get a capture, break. So we're only going to capture one. Then we will split the payloads, and we will loop the payloads and do all of our formatting like we did before. I put a couple extra things in an if statement, but that's not really necessary. All it's saying is anything less than 6 or anything that's not divisible by 2, just get rid of it because it really doesn't fit what we need anyway for hex and the length requirements. And then I used a time variable so we didn't kill our actual receiver. And you already know how to send things. We just take our formatted data and we apply our padding. So now let's send this and see how it works in real time. If we run our script and then we hit our doorbell, you'll hear it ring. But then you'll also hear it ring for each payload that's sent, meaning that multiple payloads will actually set this off, so it doesn't have to be exact. Having the ability to automate all of our attacks from the previous blog is really cool and very, very powerful. I also wanted to see if this would work against a black box target that I didn't have much information about. I sent the code to a friend who has access to a gate that he has permission to play with. The results were 100% of the time it would replay the attack and open the gate. So that's actually really cool. I've been modifying this script for more features. I'll release it soon, but basically it'll allow you to save files for the future so that you can replay attacks. It'll also allow you to choose captures that look better so that way you don't end up with junk by accident, and tackle the rolling code issues by implementing the jammer from the previous blog directly into this tool. I hope all of this was useful and serves as an RFCat primer to get you started. When I was trying to learn how to do everything with the YardStick and automate everything with Python, I literally found 0 resources on how to do this. Instead, I read the library files and looked at the data formats which were returned. I then did a whole bunch of research and figured it out myself. So I hope you found this useful. If you learned something, hit the like button. If you want to be updated of new videos, hit the subscribe button, and we'll see you in the next video.